Hi, chemistry class. This is your homework that you're going to be doing, and I want to show you how to do it. It's fairly easy. It just takes a little bit of know-how. Here is three trials, and here's the data collected in an experiment on density. It's very simple. What we're going to do is take all three of these trials, the data, add all three together, divide by 3 to get an average. This average value is called your observed value. So the observed value is your average value. Add all three pieces of data, divide by 3 to get your average, which in this case is your observed value. Your accepted value is always given to you. It's right here in this case. We get these values from the chemistry of Handbook and Physics. We get it from the Merck Index. We also get them from your textbook. There's nothing that you need to do in terms of adding, subtracting, multiplying, and dividing. That value will always be given to you. Now, what we need to do is figure out how much error is in your experiment, okay, by calculating what's called the absolute error. This is a very easy calculation to make. What you're going to do is take the value of A, subtract it from O, and then take the absolute value of that, or the value of O, subtract it from A, and take the absolute value of that. As you know from math class, the absolute value of any number is always positive. So your absolute error should always be a positive value. It should never be a negative value. The relative error is right here. That's a very simple concept to calculate as well. That's going to be your absolute error, EA, divided by A times 100. And when you calculate this value, this is going to give you your percent of error within your experiment or within your data. This number is a very important number because this is going to tell us whether we're accurate or not. And I'm going to jump up here now to this parameter here. Every experiment will give you a guideline on whether you're accurate or not accurate. If your experimental error in this case is greater than or equal to 5%, then the experimental data is not accurate. We have set these guidelines because you can be 5% above or 5% below, which would give you really a 10% range to be able to calculate your data to get an A in chemistry class or chemistry experiment I'm in. So we're shooting for less than 5% in every experiment we do at SCS in chemistry. So this is how you do this. This will be a percentage. The precision is a little different. Precision is going to take your observed value, which is an average value, and you are going to subtract which piece of data is furthest from that average or observed value. And so when we write this out, it's going to be O plus or minus the greatest difference. So whatever that difference is, it's your observed value plus or minus the greatest distance. So we take this value here, and which value here is furthest from it, you subtract those two values and put the difference, the greatest difference. Now, in regard to precision, again, we have the precision parameters listed in every experiment. In this case, if your precision is greater than 0.05, then your data is not precise. So you'll have to judge on whether your data is precise based upon this parameter right here. So whatever this number is here, it should be less than 0.05 to be precise. Or if this number here is greater than 0.05, it is not precise. The same thing with our accuracy. If this number here, after the calculation is done, is greater than or equal to 5%, then the data is not accurate. I hope this has been helpful to you. Feel free to stop it and do your calculations and then continue with the video. Good luck.